Day 2 of 9-1 today. We're skipping the 9-4 tomorrow. There's a couple of sections we don't have to cover for the state test, so we'll save them for after the state test. 9-5 Wednesday. Practice just review worksheet on Thursday. More notes on Friday. Obviously, that could change if the weather has a mind of its own. All right. Yeah, if we have a day off, then I'll just record a video. You guys can watch it at home.
No.
Whoa! This is getting way too comfortable. Telling the teacher no. That's called insubordination, and that is detention worthy. And guess who proctors? Guess who proctors morning detention page? Yours truly. 7 to 7:30.
They get a score. No one is coming morning.
All right, we had a little bit of a conversation on Friday, I believe. Let's listen, please. Can 1, 2, and 3 be side lengths of a triangle?
No.
And don't say they can if they really want to be. All right. It's not about will or desire here. Let's say that side is 3. Okay. All right. Let's say that side is 3. Shh. Let's put 1 on a hinge, and let's put 2 on a hinge. What I mean by on a hinge is those vertices can pivot. Okay? Pretend you have 3 straws. One is 3 inches long, one is 1 inch long, one is 2 inches long. Okay? And you have to make a triangle out of it. Can these make a triangle out? Can we make a triangle out of these 3 sides? 1, 2, and 3. What's going to happen? The 1 and the 2, they're going to try to meet at a vertex, and they're going to have T-Rex syndrome. What's the problem there?
It's open.
Just arms are too short. Okay, can't even reach each other. Can't even give yourself a high five. So 1 and 2 will not meet. But if they do meet, what's going to happen? It'd be on the line. That's not a triangle. All right. Let's go even further. Let's really make it obvious. Let's say that's 50. Let's say that's 10. Let's say that's 15. Will this make a triangle? No, because 10 and 15 only make 25. It's not going to meet, is it? And don't say, oh, well, I could put 10 over here. It's still, now, even though I could put 10 over here, it would come down, but that side wouldn't be 50. That side would be wherever 10 hits it. Do you agree? Are you with me? So let's make a rule. For 3 lengths to make a triangle, what do they need? What sort of rule do they have to satisfy? The sum of the 2, go ahead and finish, need to be
longer, at least one longer than the hypotenuse.
Good.
The bottom one.
Yeah. So if you have A, B, and C, doesn't A plus B need to be more than C? Wouldn't 1 and 2 have to be more than 3? Because if they equal 3, then it's not going to make a triangle. Do you agree? And doesn't A plus C have to be more than B? And then the third combination, doesn't B plus C have to be more than A? Now, what's the easy way to check it? Check that the 2 shortest ones add up to be more than the third, right? Because if the 2 shortest ones add up to be greater than the third side, then it's going to work for all 3 of those combinations. Make sense? You guys just came up with that. Very good. But what about a right triangle? Not just a triangle. What about a right triangle? So this was called the triangle inequality theorem, and we'll touch on that later. Okay, we'll touch on that later. So if you didn't write all that down, it's all right. All right, well, I'm going to make sides of a triangle that do work. I'm going to say 2, 4, and 5. Would this make a triangle?
Yeah.
Yes. Would this make a right triangle? The answer should be, I don't know yet. Okay? I didn't want to embarrass anybody and say, yeah, it's going to make a... Womp, womp. Nope. We'll see. If it's going to make a right triangle, here's the question. Must it be a right triangle? Well, if it's going to be a right triangle, what's the hypotenuse going to be called? Which length would be the hypotenuse? 5, right? So shouldn't we check to see if 2 squared plus 4 squared equals 5 squared? I'm not going to put an equal there because I don't know if it's equal. Let's see. What's 2 squared? Plus and so what's 4 plus 16? 20 is not equal to 25. Therefore, that's not a right triangle. Okay. Read my mind. If it's not a right triangle, is it acute or obtuse? Right? Not right. Acute or obtuse?
It's acute. It's the less than this one.
It's obtuse. Yeah.
Oh wait.
Let's see. Here we go. Now, eyes up here. Don't write anything down yet. Okay. If you're working with Mrs. Wolf's students, I do things a little bit differently than she did in this section. Okay. So I like to do it this way. Do you know how the Pythagorean theorem usually says a squared plus b squared equals c squared? Okay. I like to write c squared first in this scenario only. And I'll tell you why. If that c squared is greater than a squared plus b squared obtuse, doesn't it make sense if we write it that way? And c squared is greater. In our minds, can you understand how greater we can think of obtuse, right? And if c squared is less than a squared plus b squared, acute. So what was this scenario? I didn't write this the way I usually do it, but which one was the c squared?
25.
And 25 was blank compared to 20. Greater than. The c squared was greater than a squared plus b squared. So this example was obtuse. C squared was greater than. Greater than, obtuse. As long as you write the c squared first. Okay? If you choose not to write it first, that's on you. It's up to you. I'm not going to count it wrong as long as you can keep it straight. I just think it helps if you're asking the question, acute, right, or obtuse. I think it helps to write the c squared first. And then if it's greater than, obtuse. Less than, acute. All right? Go ahead and copy.
What was this one?
Fill in.
Yeah, what was that one?
What does that say?
That was actually a diagram from our last year's book. So it had the wrong number too. So we blocked it out.
Wait, so there's nothing.
Oh, that fill in the blank.
Yeah.
I thought you pointed that little box that I plugged over.
Oh, well. No idea.
Silent using the converse. So that fill in the blank above this was converse. Converse of the Pythagorean theorem. So what was the converse of the Pythagorean theorem? We did it, I just didn't call it that. Ready? Here's the regular Pythagorean theorem. If a triangle is right, comma, then a squared plus b squared equals c squared. Converse. If a squared plus b squared equals c squared, comma, then it's a right triangle. That's the converse. Did I have that filled in for you guys? I thought I put some blanks in that box. All right, moving on then. All right, this is the part that I drew for you guys, or I already drew an example. We determined whether it was a triangle or not. This is called the triangle inequality theorem. Okay? If you're given A, B, and C, then to be a triangle, A plus B needs to be greater than C. A plus C has to be greater than B. and B plus C needs to be greater than A. This is called the triangle inequality theorem. So given sides of A, B, and C be a triangle, A plus B has to be greater than C, A plus C has to be greater than B, and B plus C has to be greater than A. Man, this gets messed up a lot. Is this the converse of the Pythagorean theorem? I don't see any squares in there, do you? I don't see an A squared, a B squared, a C squared, do you? What is this checking for? It's only checking to see if those sides can make a triangle, can touch, can make a triangle. Does it tell you acute, right, or obtuse? No. Do you see how students could think that way? Oh, C squared is greater than A squared plus B squared. Obtuse, yes. But these don't check for obtuse or acute. These just check for can it make a triangle. And what did I do? Just for your own sake. I did every combination of two sides added together. I did A plus B, I did A plus C, and I did B plus C. And if all three of those combinations add up to be greater than the third side, it will make a triangle. If one of them fails, what if one of those inequalities fail? Conclusion? Not a triangle. We good? All right. 5, 7, 10. What should we check first? Acute, right, or obtuse? No. Check to make sure it can make a triangle. Is 5 plus 7 greater than 10? Check. Is 5 plus 10 greater than 7? Check. Is 7 plus 10 greater than 5? Check. So yes. Thanks, Jackson. Makes a triangle. Second, what type of triangle? Now, I know what you're going to ask, especially the lazy people. You know what you're thinking. Mr. Westphal. That's a lazy voice. Okay. Do I really need to show all three? Preston! Coming out savage on a Monday morning.
Yeah, Bryce.
Yeah, right? Were you? Did something traumatic happen to you this weekend, Preston? Deep down anger. Ryan, are you right?
Yeah.
Just wipe yourself off a little bit. You'll be good. All right? Get back at it. All right. Yes, you need to check all three. You'll see why later. To be continued. All right, next. What type? Okay. What did I recommend? If you're checking to see what type it is, what should you put first?
C squared.
C squared, right? C squared, I'm going to put a question mark, and then A squared plus B squared. We're going to let the numbers speak for themselves. I'm going to put 10 in for C. 10 squared, question mark. Does it matter whether I call A or B 5 or 7? No. 5 squared plus 7 squared. What's 10 squared? 100. What's 5 squared plus 7 squared? What's 25 plus 49?
79.
25 plus 70.
84.
82. 84.
84. 74.
74 sounds right. It's all right. Third time's a charm.
We got it.
All right. If you did it the way I recommended and the way in your guided notes, the sign we're about to put there will tell us our answer. Greater than, less than, or equal to? Greater than. Greater than, with C squared being first, tells us this is going to be obtuse. Obtuse. So yes, it makes a triangle, and it was an obtuse triangle. Do you see how a student could look up here and say, oh, 10 is less than 12 acute? You see how that, if you didn't study, if you didn't practice this, they could do that. They could look at the triangle inequality theorem and compare the C side and the A and the B there. That's not it. You have to look at the C squared and A squared plus B squared. Okay. Next one. Try it on your own. All right, you done?
Yeah. Got the big.
Ryan,
No, it doesn't.
are you being lazy or you do it?
Lazy.
You do it?
Do it.
All right. Preston got his back.
18 plus 5 doesn't equal 17.
Is 5 plus 8? What's the question, Ryan?
Equal or greater than?
Not equal.
Oh, greater than 17.
Greater than 17. No,
Or you can know the other something else.
not a triangle. Not a triangle. So don't even worry about classifying it. It wasn't a triangle to start with. Next problem. This time I'll give you a little bit more time. Hint, hint.
What's 16? What's 16?
C squared, the greatest one.
Greatest one is always C. If it's going to be a right triangle, the biggest one would have to be C. So we have to call that one C every time.
Yeah, it always
What? What is it? Wait, what's that? 7 times 7 is 14.
Plus
I'm pretty sure all three of them are. Yeah, okay, that sounds too.
Oh, yeah.
Is that 193?
yeah.
You got 2.
Yeah, I got it.
Mess with me, Anthony. Don't mess with me. I'm just kidding. All right, next.
Oh, I know. What's only do the shortest one? I thought you're saying.
No.
Yeah, I thought you're saying. Yeah, I was opposite.
All right. Is 11 plus 24 greater than 18?
Oh, yeah.
11 plus 18 greater than 24? And 18 plus 24 greater than 11? So yes. Next. Type. What's our hypotenuse going to be if it is a right triangle? 24. So 24. Now, is it called a hypotenuse if it's an obtuse triangle?
I don't think so.
No.
That's what I'm
24 squared. Question mark. 11 squared plus 18 squared. Help me out. What's 24 squared?
576.
And what's 11 squared plus 18 squared?
445.
Man, these are all obtuse. Did you get obtuse?
Yeah.
Man, I can't think of any triangle that's not obtuse. Can you make one? Let's skip the obtuse one. Can you guys make one that's acute? Go ahead.
Oh my goodness.
That was kind of a trick, Brian.
So it is not.
He's actually.
You can't do it.
There has to be sides of a triangle that's acute. Go ahead. Make 3 sides. Now, that are acute. She says I'm just going to copy it. It's not possible to make it acute?
But you have to check. You have to check if like all the things are like.
You know what? A wise person or poster once said, just because something's difficult doesn't mean you shouldn't try. Just try first.
What do you do?
Motivation of the day.
I was thinking maybe.
Alright, so what do you
It's like 7, and then let's just like.
I'll send you smoke.
It's like 6. 6 or 7.
Alana, you got it?
10, that's 16. That's not a right triangle. Close enough.
What'd you get? Alana says, what about 3, 3, and 3?
Oh, good idea.
Alana, that was brilliant. That was life-changing. Because what do we know about equilateral triangles?
They're always.
They're also equiangular, and if they're equiangular, all their angles are
I keep.
60. Alana, you get a gold star for today. Math award. Well done. Let's check it. Let's make sure Alana is right with her logic here. Is 3 plus 3 greater than 3? I hope so. Let's check the other two. Is 3 plus 3 greater than 3? And then the last combination, is 3 plus 3 greater than 3?
I don't think so.
Yes. Next. Type. Is, let's see, 3 squared, question mark. 3 squared plus 3 squared. 3 squared is 9. 3 squared plus 3 squared is 18. Would you look at that? We got a less than symbol. Less than, if it's ordered this way. Acute. Acute. Thank you for instilling knowledge in us, Alana. I appreciate that. Questions on that? All right, I'm gonna make you guys a deal. I'm not gonna make you copy any. We're gonna stop there for today. You have, again, half of a day's lesson. Even though I took 2 days on this, I did not. I took 1 day's worth of homework, and I split it up into 2 days. Got it? So I'm not a busy work person. I'm not going to give you busy work because this is a new day. You should have new homework. All right. I will give you the same thing. Just tonight. Here's the deal, though. I'm going to put it up in a second. I need to at least introduce the lesson that we're going to do for tomorrow. Deal? Okay. I need to introduce tomorrow's lesson because we are a day behind because of my fault, the quiz. So I'll put the homework up in just a second. 9-4, I'll get you the guided notes tomorrow. 9-4, just sit back and relax and listen, okay? It's called the tangent ratios. Have you ever heard of sine, cosine, and tangent? Where have you seen them? Just heard about it. How many of you just heard about it but have no idea what it is? Okay, so how many of you know about it? Not only know about it, know what they are used for. Preston.
They're used for triangles.
How?
I couldn't tell you.
Fair enough. This is exciting for us because pretty much every other math concept you guys learn, like, it's a geometry setup, but then you solve it with algebra, right? So this is something I get to introduce to you guys for the first time, and it's pretty cool, pretty interesting. All right, tangent. It's not a guy who's been sitting on the beach for too long. That's a tan gentleman. All right. Wow, that was a bad one. You guys laughed. Are you guys okay?
It was so bad.
Should I start
that
taking
laugh.
temperatures? Like, is it sick? All right. So here we go. We'll copy this down tomorrow. But a trigonometric. Ready? Oh, stop it. You guys are supposed to just sit back and relax. Don't complain. All right. Ready?
Trigonometry.
Try. Ooh, let's break it up. 3. Very good. All right. We'll get to that in a second.
Oh wait, yeah, because metric.
Metric is to measure, right?
Yeah.
Metric is to measure. Oh, stop it. You guys are terrible. All right. That actually means study of. Okay. I don't know. We're not going to get off into this. We're not going to get off on a tangent here, but that means study of. So we're actually studying the measurements of triangles. We're studying the measurements of triangles. That's all it means. Trigonometry. This is the study of the measure of triangles. All right. Now, a ratio of the lengths of two sides in a right triangle. Again, this is only for right triangles, what we're about to do. Guess what? Pythagorean theorem was only for right triangles. Specifically to do what? What's the purpose of the Pythagorean theorem? To find the length of a side in a right triangle. Yes? One more time. The Pythagorean theorem is used to find the missing side in a right triangle if you already know what? Or? So in general, two sides. Either a hypotenuse and one of the legs or both legs. Do you agree? We can find the third side using the Pythagorean theorem. That is the purpose of the Pythagorean theorem. But what if you have a triangle where you know this angle is 40 degrees and this leg is 12? Can't use the Pythagorean theorem there, can you? Because the Pythagorean theorem is used for sides, and you already have to know two of them. Yes? Mm-hmm. You, my friends, and those who hate me, will use a new process to find the missing side if you know one of the acute angles and one of the sides. This is the process we're going to use. Okay? So a trigonometric ratio is used to solve for missing pieces in a triangle if you know acute angle and a side. You with me? Does that make sense? Even if you don't understand what you're doing yet, that's what we're doing. That's where we're heading with this. Okay? So, that's a lot of reading for today. The tangent ratio is a trig ratio for acute angles that involves the lengths of the legs of a right triangle. All right, so here we go. First one. Let's call this A, B, and C. And again, we'll fill this in tomorrow. A, B, and C. I just want to introduce this. We'll get in depth and solve some problems tomorrow. The tangent ratio, okay? Here's how it's going to work. The tangent is a ratio. What is a ratio? It's a fraction. Okay, that's why we did a ton of ratios before this. And here's one of the rules. you always have to take the tangent of an acute angle. So let's take the tangent of A. Do you agree A and B are both acute? They're both acute. I could have taken the tangent of A or B. It's going to depend, and I'll show you where how that depends on what information tomorrow. Today we're going to do the tangent of A. The tangent of angle A equals, it's the ratio of two sides. I'll give you a hint. The numerator is the opposite side. Okay? And the denominator is the adjacent side. Well, what does that mean? Ready? I'm going to put my finger on the angle I'm talking about. I'm at angle A. I could have done B, but I'm not. I'm picking angle A for a reason. I'll do it with angle B here in a minute. If I'm on angle A, what would your guess be as to which one is the opposite side from angle A? What do you think? Who you don't know yet. Just what would your guess be? How many of you vote side A? Opposite. How many of you vote side B? And side C? Okay, good news for you. In every right triangle, there's going to be, and two of these three can change, an opposite side, an adjacent side, and the hypotenuse. The hypotenuse cannot change. What's the hypotenuse? So from angle A, opposite and adjacent. What did adjacent mean before in math? Next to. So what two sides come together at angle A? C and B. Well, C is called the hypotenuse. It's out. What's the adjacent side to angle A? B. Do you agree? Because it's touching it. It's next to it. So what's opposite of angle A? Side A. So the tangent of angle A, what's the opposite side again? Little a, side A, over, what was the adjacent side to angle A? B. Side B. This is the tangent ratio. It's always going to be opposite over adjacent. You can memorize that. Opposite over adjacent. Tangent is opposite over adjacent. Ready? I'm going to move my angle. Now I'm up here at angle B. All eyes up here. I'm up here at angle B. My finger is at angle B. The tangent of angle B is, well, what's the tangent rule? The ratio is blank over blank. Opposite over adjacent. Well, guess what? I moved my finger. What's opposite of angle B? Side B. What's the adjacent to angle B? A. Why can't it be C? C is always the hypotenuse. C will only be used when we talk about sine and cosine. The hypotenuse is not used when you're dealing with tangent. Does that make sense? Yes? That is the tangent ratio. All right? It's always of one of the acute angles. Never put your finger on angle C for the tangent or sine or cosine ratio. You'll deal with that in pre-calculus, but not in this class. All right? So the tangent ratio is opposite over adjacent. And we'll write that out tomorrow. And your homework for tonight is 10 through 22 even. All right? 10 through 22 even.